We are live. Good day, my EOS friends. Welcome to the EOS Podcast. Today we have Greg Simpson, the founder of EDNA, and we're going to go into what EDNA is, why we need to be protecting our digital DNA, if you will, and just all about EOS. And this is an exciting project. So, Greg, it's great to have you on the show. Go ahead and introduce yourself.
Hi, Brandon. My name is Greg Simpson. Thanks for having me. First off, my name is Greg Simpson. I'm a computer programmer, data specialist in databases for about 20 years, and got involved in biology about 7 years ago when the HIPAA compliance rules changed. So that's what dragged me over into the biology side. And of course, when I lost out on a very major number of Bitcoins that were going to be given back to me as payback for a loan in about 2010, I turned it down, and I regret that. But that was my introduction to crypto. I lost a heck of an opportunity.
That's one of the one of the war stories that you hear from a lot of people who've been in this for a while. They have that one big loss that would have kind of been a game changer. So, well, you at least you didn't buy a $10 million pizza or something like that.
No, I didn't do that.
Well, what has you most excited in general about EOS right now? Probably
the insane pace of everything inside the ecosystem. You know, it feels like I've been here years, and it's only really been a few months. Mm-hmm. And I mean, every single week there's a whole world of new things popping up on EOS, and new people joining, and oh, we're going to build this, we're going to build that, and it just never seems to stop. Even just keeping up with who's in the space is near impossible. That's exciting, because that's really what I see coming together is a system that really fulfills the promise of what EOS says it's going to do. And we're seeing it happen.
Yeah, absolutely. I mean, it happens so quickly, and it does feel like a week equals a month or a year, even sometimes in cryptocurrency. That's why I do the EOS podcast so often, is because to keep up myself, I have to just be like diligently asking questions and digging in, or else it's, you take a couple weeks off and it feels like you're new to the game again. So
it's true.
Yeah. So, on that note, something that I kind of missed that we'll get into a little bit deeper was your guys' staking program. And when I saw it, that you guys have a great staking program, I was like, man, there's these opportunities that are popping up all over the place. That you got to stay on top of, and so your staking program is one of those. But let's get into kind of EDNA first, and then we'll get into your cool staking program later. But why don't you tell people why it's important to own your own DNA and what you guys are doing?
That's key to what we believe in. If you have a look at our Constitution, it's property rights. This is your property. Worse than that, your DNA is not like your driver's license or your address. Those things are about your identity. They give hints about who you are. You live there, you drive this car, here's your social security number. These are about your identity. DNA is your identity. It technically is. This is how, people go to prison for life, because their DNA matches the DNA that was found at the scene of the crime. So if anything that you truly own or should own in this world, it's your DNA. And we believe that people are being nefariously treated by most of the organizations out there that do sequencing, because they're selling this DNA. It's a really great deal for them. You pay them to take your property, and it's digital property, so they can copy and paste it as many times as they want and sell each copy. Okay. And so they're making a fortune. Not only that, there's gold in our DNA. Scientists, we understand about 1.5% of what our DNA does. It's a very small amount. What the FDA allows us, which is a totally different topic, but throw it in here. What the FDA allows us to know about is 10 of over almost 50,000 items that we know are pathogenic inside our DNA. So in a DTC, direct-to-consumer reporting, the FDA will allow you to learn about 10 of those. This is actually a second problem, but the importance of ownership is one, if you don't really take ownership of this data, you're not going to get to know what's in your DNA. That's kind of can maybe change your life. If you find out you have a proclivity to a certain drug. Matter of fact, I got called in on this not long ago. There was a healthcare worker that I'm close to that turned around and said, we almost lost somebody today, but if they had had their DNA sequence, we wouldn't have lost them. We gave them a bad drug. It almost killed them. Wow. So, there's a lot of uses that it's very, very important to be informed. But if you don't take ownership of it at first, they're not going to tell you. They're under no obligation. You read their terms of service. They don't have to tell you anything. They're going to tell you how much Neanderthal you are and how much Viking you are. And that's cool, right? It's fun to know. It's fun to share with your friends. But it really is like a joke compared to the true information that's available inside your genetics. And with the future world of CRISPR and our ability to change our own DNA, that even becomes more important.
Yeah.
So that I hopefully is an introduction of why.
Yeah, that's a great introduction. I mean, it sounds like there's kind of two parts I'd like to dig into there. There's one is the kind of the privacy issue, and then the other part is the use case. So let's get into that use case a little bit. You said that there's a certain amount of pathogenic, which basically means things that are harmful to you, right? There's a few that we can see, but there's a bunch that they don't give us access to, but this would unlock that potential where we'd be able to see all of the pathogenic parts of our DNA.
That's the intention, and obviously the FDA prohibits this. So one of the things that the way I like to tell the story is the BRCA genes. There's about 1,000, actually over 1,000, just barely. Known variants inside the BRCA, BRCA genes that can cause breast cancer. Now, Angelina Jolie is wealthy enough to have her entire genome studied and poured over by people, and cost quite a bit of money to get this sort of service done and do a full exploratory on how many of these 1,000 are potentially could cause problems for her, which is why she had her breast removed. She would not have done that on a consumer report that the FDA allows 3 out of the over 1,000 known issues to be discussed in a report. But because we store DNA data in the open, and there's a very specific identity protection system that we've come up with in prototype that would prevent anyone from actually getting a hold of your DNA, but the DNA can be seen and essentially tagged. And your wallet would know that your stuff has been tagged and be able to retrieve data. So it's a very private way to get a report. So someone could come along and write this report. And if they stuck it out on the blockchain, this sort of code, the FDA would have to go arrest the blockchain.
Mm-hmm. And why is it that they only allow the three to be put in a report? Is that a financial decision, or what's behind that?
So I called the FDA. I spoke with them. I said, "What gives, man? This is ridiculous. Why even bother giving anyone a report? You're actually bearing like huge, ginormous amounts of data.
It's a disservice, yeah.
Yeah, you're supposed to be protecting health and safety. How are you doing that if you're hiding information? And so who made you the information police? This is not a treatment. This is not a shot. This is not a medicine. This is not a pill. Mm-hmm. How is this health and safety of the American public? And so the response was, well, we're afraid that people might jump off bridges if they learned about, their potential for sicknesses.
Oh, wow.
And I'm like, okay, that's not true. It's just, I'm not buying it. So I dug a little. And what it turns out is that majority of the ones that I checked tied in directly to big pharmaceutical research programs that I could uncover. They were working on that variant. So once I found the study that the pharmaceutical company was now funding this exact variant and working on it and trying to create a drug or had a drug in clinical trials, it's the money chain. Now, the FDA is the only U.S. regulatory organization in America that is allowed to take funding from the people it's supposed to be policing.
Mm-hmm.
So think about that, right? The cops in your neighborhood are taking money from a group of people. Actually, 3/4 of their income is coming directly from these people that they're supposed to be making sure aren't doing anything bad.
Yeah. Well, I mean, it's almost, at this point, it's almost common knowledge that the drug industry is a, pretty shady operation. So let me explain that, how I kind of heard it there. Tell me if this is right. So there's this certain amount of pathogenic variables, maybe 200, let's say. Was that accurate, about 200 or?
No, there's 50,000.
50,000. Okay. There's 50,000. And it sounds like, so what the FDA wants to do is control the ones that we can see as they can be monetized. So we can fix, or we can sell drugs for these three. So we'll put those out there and we'll release them as they can be monetized. These other ones that aren't yet monetized, we'll hold back and we'll tell you about them as we can give you drugs for them. Is that?
You're exactly dead on. You're exactly right. And so what that means is that Big Pharma is saying, FDA, make that, we don't want anybody to know that they have this issue till we have a drug that we can sell them and make them take it for the rest of their lives.
Mm-hmm.
Now, a CRISPR edit or a treat, this is a cure. When you actually alter the DNA, your body, you're not fighting the body, because the DNA is the root which creates proteins and enzymes. And that's what the drugs can manipulate, those proteins and enzymes. But if the body's not doing something bad based on the DNA telling it to, well, then you don't need the drug, Well,
yeah, that's the ultimate, like the treatment of the cause as opposed to the symptom right there, isn't it?
Exactly. You nailed it.
Well, so that's amazing. So really, a big part of what EDNA is a company that just wants to get this information out to everyone has it, as opposed to right now we have such a huge middleman as the pharmaceutical and the FDA and these companies that are kind of standing there because it's, with kind of life or death on the line almost. There's a real huge opportunity to monetize. And you guys are looking to step in between and decentralize such a big play there. That's a bold move. I like it.
We do too.
Yeah.
We believe that people should not be suffering out there because of somebody else's bottom line and profit margin, and they're not going to change until we produce a better system. And the better system is that the owner of the DNA gets to monetize it. If they want to, share it with a researcher who they believe in, somebody that's actually working on, some real cures out there, EDNA as a community will vet their research programs and then produce it as a contract to the DAC. And if you want to opt in and share your DNA and help these researchers out, you're going to get paid for it. Mm-hmm. Not only that, but there's gold in that land that's being copied. One of somebody's genetics out there, you can't get cancer. We know they've already found people from Northern Europe that were plague survivors. Essentially, their distant relatives were plague survivors. So they can't get AIDS. Their bodies don't produce. It's called the HNM5 gene. They're both knocked out. They're turned off. So they don't produce receptors for the virus to bind to. So they can swim in a swimming pool of it. It's a cure for AIDS. And so somebody's genetics that came out of that, and what's that worth on the market? Once an edit is possible. So there's huge amounts of gold in here, and we're giving it away. We're actually paying them, to take our land and copy it as many times as they want and go mine the gold out of it.
So are these edits? Are they something that can be basically patented? If someone patents say to turn off the gene for cancer, is that something that only they'll have control of, or is there with CRISPR, is it just there's not the opportunity to patent?
There's a very big struggle in the courts right now, and it'll go on for decades, only because of how many people claim to have invented CRISPR. Jennifer Doudna is out of California University, actually, is the one who came forward first as far as anyone can tell. But there's a lot of noise and scientific struggle over this. So CRISPR is not going to be patented till it's probably antiquated.
Mm-hmm.
The current version is Cas12. They started out with Cas5 that had in humans, which had some issues, but it's being constantly versioned and improved on. So this is going to be a mess in the courts for a long, long time.
Yeah.
And you can call up the ADGENE, ADDGENE is a service. It's a nonprofit. And if you know what you're doing, you can order up your exact CRISPR that would flip the exact, one letter off of your 6 billion letters and snip it and either insert something or delete something right at that point. And that's about $350.
That is amazing. So for people who don't know what CRISPR is, maybe give a brief explanation of what CRISPR is.
CRISPR is, bacteria have an immune system. Bacteria are attacked by what's called bacteriophages. And we should just think of them as viruses attacking us, right? So what this bacteriophage does is it injects its own DNA into the cells of the bacteria, and then it goes to work killing the bacteria. And that's how this virus for bacteria worked. Now, bacteria got smart, and they started stealing a little bit of their DNA, and it put it inside their own DNA. It inserted the bacteriophage's DNA in it. And so the next time a bacteriophage came into the body, the bacteria's body, it would go, oh, I recognize you. You're a bad guy. I'm going to kill you. So the immune system kicked in for the bacteria. Now, scientists figured out, well, shoot, this thing is creeping along 1 million letters of DNA and finding that exact code right there and matching it. This is pretty cool. And so we basically took their enzyme and used it in mice and humans and just about anything else that has DNA. And so what it does is it can be programmed to go along the DNA, find an exact sequence, and it cuts. But it can also carry a little piece of DNA with it that will match that cut, right? Letters line up here, letters line up here. So now it's inserting. This is called a knock-in, or if we just cut it, it's going to be a knockout, and that gene will not do what that gene's been doing in the body. So there's the insert and delete key for our Word document that is our DNA. And it's super, super accurate. Think about it, 6 billion letters, and it's got a 20-letter code that has to match that 20-letter code. Bingo, done.
That's amazing. So essentially it enables us to go down and like you said, a Word document's a great description, just edit, delete, add a part of a DNA and change how sometimes, so turn a gene off and sometimes edit what it actually does.
Sure. And there's a lot of other things going on in DNA just besides genes. There's areas of DNA that create promoters for that gene to make it work harder and produce more.
Okay.
And then there's suppressors that will affect the genes next to it and say, no, you be quiet now. You're old. Don't do that. Don't make any more muscle. You're old. But so there's a lot going on in our DNA besides just a gene. Most people don't realize that, but it does give us control. And frankly, the hardest thing we've got right now is efficacy. You could rub this CRISPR juice on your skin and you'd affect a few cells. You could shoot it in your bloodstream and you'd get a little more of a cells affected. You could inhale it. You could swim in it. You could take baths in it. You could basically use a gene gun, and with little tiny gold bullets that had the CRISPR edit, you could start smattering it into your skin cells. And our skin cells are very easy to attack and edit with CRISPR because they change over every 30 days. So they're constantly refreshing themselves. Bone cells, not so much, or livers and kidneys, not so much either. And a skeleton is the worst. That's a lifetime. So it's very difficult to CRISPR edit bones currently. That won't stop these guys. The technology is advancing every day. You can't even read the papers. I can get through the abstracts, for most of the papers that I'm interested in. And I subscribe to a lot of different journals to get, my information from.
So where are we at as far as CRISPR being able to be administered like effectively to people? It sounds like right now it's pretty minimal, but it's
been done. It's been done. Emily Whitehead in 2005 had a totally devastating disease. It was going to kill her. She She was a very young child at the time, and she was the first one to receive CRISPR edits. They extracted her blood, edited her blood. It's a form of leukemia she had. She would not have lived out the year. This was done in 2005, and she is alive and well today, cancer-free, and doing fine. So, it's you're going to hear about it more and more and more as it gets through the medical process of trials and approvals.
Yeah, it seems like blood cancer may be one of the first areas that it would work because you're going to be, like you said, you can the blood is the blood an easier one to get to and change the cells in? It seems like
exactly. Once you can pull it out and do this in a dish, you can get very astute with making sure the blood cells have the cell wall has been penetrated by the CRISPR edit. Right, you got to get through those cell walls to get to the DNA.
Yeah. I used to work at a cord blood registry in the Silicon Valley there, and we did cryogenic processing of embryonic stem cells, and then we'd save them and then use them to treat diseases in the future for kids. And one of them was blood cancers, was one of the big ones that we'd hit on, lymphoma. So it was one that we were able to treat pretty successfully, which was just amazing to think that those things are going on, so.
Well, it's very cool stuff. I mean, all that stem cell has got the potential of those as well. And it's like, geez, so now I can grow a new eyeball and it won't be rejected. And, once I make them back, strip them out and make them pluripotent again. And so they could be anything in my body. And
I mean, that's a huge area. So yeah, well, so that's kind of the application. I mean, it's almost endless. So it's clearly really important that someone steps in and gives people the opportunity to own this or have control over it for themselves. So what do you think on the other end, kind of the privacy end? So that's the application. And on the privacy end, right now, people in droves are giving their information to, like Ancestry.com and 23andMe and these type of things so that they can, like you said, find out what % Neanderthal they are. What do you think? Do you think there's anything necessarily nefarious going on that end besides them? I mean, so as an individual, if I gave my information to them, is there something, do you think, some sort of consequence that could happen directly to me, or is it more the consequence of just not having control over my own information?
I just don't find it to be a good idea. That's your identity.
Yeah.
It's sort of like, it depends on how far in the conspiracy theories you want to dive. I mean, there's information out there that says, there's some very nefarious things they could be doing with that. Mm-hmm. The other thing is, once you give up rights, 23andMe or Ancestry can be selling this to biological weapon manufacturers, and you can't say a word about it. You've already handed over those rights to monetize your data. And I mean, that is still ownership, right? That's not privacy. But I still think it's a hugely bad idea to go around sharing your DNA with people.
Yeah.
I just wouldn't do it.
Yeah. And you used an example of I heard you use a good example of like your grandfather giving you a box with something hidden in it. You didn't know what it was. It could be worth it could just be old playing cards, or it could be worth like $10 million or, some sort of, what was that analogy?
Well, so, if your grandfather died and this was how the story went, and you were in the lawyer's office getting the will read, and your sister got her island and your brother got his fleet of yachts, and then the lawyer came to you and said, well, your grandpa left you this box. And you're like, well, what's in the box, Grandma? And she goes, well, I don't know. He could be anything in there, but the key's on the desk in your grandpa's study, and you can unlock it and go see what's in it. And so you leave the lawyer's office with this box, and there's a guy on the front steps going, hey man, are you hungry? You want this pizza? I'll trade you this pizza for that box. Are you going to do that?
Yeah.
I mean, really go look at what's in the box before you go handing it away. And because published science, the ones I can get my hands on, say 1.5, tell us what 1.5% is in the box. So no one really knows yet what's in this box. And to give it away for a pizza is really kind of silly.
Yeah. Well, I mean, I think that's a great analogy. We just don't, you're you're giving away something that could be, the risk reward there is just really asymmetrical to, it's a good way to look at it if you care, if you're kind of a risk analyzer, you could be giving away, the downside's big there. So, so let's talk a little bit about what you got, how EDNA's made up, how the DAC's made up, how your company's operating, why this works on the blockchain.
Okay. One of the things I mentioned earlier that we need to keep the data in the open. And how we do that is essentially there's a thing called a GRCH38, which is the standard reference human genome. It's the most common DNA for all 6 billion letters, right? And where you vary and where I vary are about 3 million places out of there. So instead of 2 gigabits, I only need 5 megabits of data to describe where you vary. So we extract that. Then we take 5,000 other people and extract their 3 megabytes or 5 megabytes. Now we tumble them all, but they each have a unique identifier on them that are in your wallet, right? So your wallet can reconstruct and pull off chain all your 3 million variants. And now that they're tumbled and on chain, no forensic scientist, no forensic lab, nobody could ever reconstruct your data without already having your data in its hand. Not only that, they'd have to have all 4,999 other people that you were tumbled with. So we're very certain that this identity is protected against forensic attack. They will never be able to say that's Greg on the blockchain, not without the private key.
Yeah.
The DAC is structured simply because when you start talking about CRISPR, you're talking about some pretty serious ethical questions coming our way in the future. And I didn't want to be one of those people that was sought out for my opinion, because I feel my opinion's one person's opinion. And while I believe it's a pretty informed opinion, it's also still one person's opinion. And so I started to learn about DACs and how DACs were structured, and that they can elect custodians and begin to get business done at the same time, are really essentially owned by the people who own the DNA, which to me makes total sense. This is how you stay out of trouble. You take votes from, because it's the internet now, and we all don't have to march down, even though we still do in our country, march down to the polling office and check off who we want to vote for. Now with the internet being able to create a community like this, decentralized and representation from Africa and Asia and South America and all around the world, all of a sudden we can have a true representation of custodians elected for us that we can monitor them. We can watch their voting records. If it's on blockchain and their votes are counted there, we can see what they stand for, what they're fighting for. And the idea behind our DAC is we're going to make that super easy to track and watch over. You're going to get a little app that can watch how are your custodians doing what you're supposed to be doing for you. Do you agree with them? And if not, next 90 days, get rid of them and get somebody else in there who promises to do it. Not only that, EDNA will be paying for a 10-minute commercial for every custodian who wants to run. And that 10-minute commercial is just simply something like this, where, and it will be against DAC rules to go pay for some other trying to influence an election. You get your 10 minutes to state your views and compared with, everybody else out there who's running. What I'm saying is that the EOS blockchain and DACs in general are a tremendous way to manage something. And I think that there's important enough, and there will be ethical questions like, what about the unborn? Are we going to edit them? What about the neighbor kid who comes over and says he wants gills because he's a surfer? Can he have gills? Should he have gills? Should we stop him, from changing his identity? It is his identity, but there's an argument there. There'll be people that have very strong opinions on these things. And I think a DAC is a safer world to work those out in versus asking what Greg thinks. I don't want to be that guy. I don't want the responsibility.
Yeah. Well, and it's just the longevity of something like a DAC as opposed to having decision makers along the way. You never know how that mutates into something, 100 years from now, or 20 years from now.
Exactly. The ability to be corrupted.
Yeah.
I'm one guy, and did the deep state get to Greg, and is he's given up our data? I don't want that.
Yeah.
The DAC is the right method.
Yeah, absolutely. That is just, so the concept of the concept of being able to change your DNA and then change your physical appearance or like your abilities and things is such a, it just makes it seem like the world is going to change so much in the near future. How far off do you think the technology to do pretty big physical changes or use CRISPR to do pretty big physical changes is?
Man, you have to understand these people will do it.
Yeah.
What can be done will be done.
Yeah.
And I think that they're very, very close to being able to understand this.
Mm-hmm.
A lot of the issue is I've read some recent work on using ultraviolet light to help the penetration of the CRISPR edited into the cell. And, if they can basically burn it in through the cell wall, they're going to do it. And I hesitate to guess. I think it's coming way faster than anyone anticipates, and it will look like science fiction to most of us. Some of us will be blown away and shocked.
Yeah. I know that already it's possible to edit. You can change eye color and like height, how tall people are, genes in unborn or in babies.
Yeah.
Right?
Wealthy people now go to clinics and they have, hundreds and hundreds of eggs screened. And they make sure that their children won't have any disadvantages genetically. Yeah. And if you have enough money, you can do that too. And that will become very commonplace as the cost falls. And the cost to do anything in genetics is falling extremely fast, well beyond Moore's law.
Mm-hmm.
When you look at it, in 2001, it would have cost you $100 million to get your DNA sequenced. Now, I can do it in my kitchen with this device for about $1,000, and it's USB powered.
Wow.
Jacks right into my computer, and off we go. 2 days later, I'll have your whole 6 billion letters.
That's amazing. Wow. Okay. Yeah. So just that makes how quickly the technology is advancing, and what we're going to see just right around the corner makes this almost it's like a time sensitive issue as well. The sooner EDNA can kind of get established, get things on the blockchain, get people secured privately.
Yeah, unfortunately, we're behind our competitors and those people that they're household words now.
Mm-hmm. Mm-hmm.
They're household words already, and EDNA is certainly not a household word. We're going to have to act quickly if we're going to preserve our rights, because as has been reported recently, about 60% of Americans can be located in databases like 23andMe and Ancestry because one of our relatives did it.
Oh, yeah.
So they can figure out about who you are. Now, they can't nail you down perfectly, but they can get really close because your cousin did it. And so if they look for a certain DNA pattern in there and they go, oh, that's who that is. Who's he related to? We know he's a cousin.
Yeah. What kind of uses are there for DNA metadata? So if there's that much kind of data in these databases, what type of uses are there for the big data?
Well, I would think that number one use would come from insurance companies, that they would certainly want to know who's at risk for heart attacks, who's at risk for cancers, who's at risk for whatever they're at risk for, and when to expect them to get it in terms of aging. That's one other need for privacy, is that shouldn't be allowed. At least I don't think so. Mm-hmm. Until there's something that can be done about it. Because right now, changing your DNA is a very difficult, experimental, not an everyday procedure. If it were an everyday procedure to say, okay, I'm going to prevent my heart attack at 52, that would be all right for an insurance company, I think, to say, well, you didn't do it. You should have.
Yeah. Yeah. Well, and maybe if people are owning their DNA and realizing a lot about their self and their health risks, maybe they will be less risky for insurance companies down the way. But But yeah, that's quite a concept there, because you can picture, I mean, insurance companies will be able to, with this information is invaluable to them, they'd be able to tweak their algorithms to such a high extent that their risk is disappearing quickly as far as who they're insuring or how much it costs for people. I mean, and they're already winning that game anyway. So
yeah, they're ahead.
yeah. So we talked about the airdrop or the staking, excuse me, for EDNA. That is something that I wanted to mention because I'm going to get on and stake my EDNA from the Genesis airdrop that you guys did.
Oh, cool.
What's your staking program look like?
Well, we have a website. It's integrated with Scatter. So if you head to edna.life, you'll see a staking choice on the menu, which will then take you to the staking website, and you can stake your coins either weekly, monthly, or quarterly. So weekly earns at 1, monthly earns at 1.5, and quarterly earns at 2. So each week on Fridays afternoons, we put our payout up there for the next week, and we have 100 million coins to spend. We're down to about 53 million, I think. It's going very fast because the program has been a big success in the number of coins that we got staked. That reward, then if you're quarterly or monthly, will flow into escrow. And we've been paying out for quarterly stakers right at 6% a week each week for the last, I don't know, 7 or 8 weeks. They made some pretty terrific returns on their stake. But we see it as a thank you to the early investors, and in particular who want to hold our coins and give us a break so that we can buy some time to get the DAC set up so that then they have something else to do with their tokens.
Yeah. I mean, that's great. That's a good, that's a good reward for people who are not just, that are holding on to their coins and supporting the project. So I like that. I think that's a good trend. I've seen some of the other quality dApps out there doing that as well. So, yeah, it
does make sense to give back a little bit. And these were non-inflationary tokens that we're giving out. These were planned marketing tokens from the beginning. So we're not reducing your price. We're just giving you more of what we already gave you.
That's awesome. Your roadmap coming up, you've got the DAC membership launching fairly soon. Is that in the next couple months or so, or how's that panning out?
Actually, we've got that one targeted for November. We were going to go November 1st. It's probably going to be much closer to later in the month because we're adding in an investment program inside the DAC code. We want to keep it as a part of the same contract. Upgrading on EOS isn't necessarily that hard to upgrade a contract and add features. We've already done it. Our original token was just an EOS IO token delivered code from EOS. And then we upgraded it with the staking code in it, so we've been this route once before. It's not very extremely difficult. There's a lot of testing though, especially when you consider now you've got people's money on this. And I think we tested that code probably 7 weeks hard every single day, pounding on that code. And fortunately, not a single letter had to be adjusted because of our testing. I blame it, because we did find a lot of things in testing. And while none of them would have been catastrophic to anybody's token ownership, we're still talking money. So we've got to be very, very careful. The idea is I don't want to do 7 upgrades to get to DAC. I want to try to do it in as big a bite as we can. And what we know and are confident in terms of the code and the features that we'll be building in, we're on target for, say, end of November. Very worst case, early December when we can go live.
Great. And then on your roadmap, you also have lab upgrades and then going on chain in April of this next year. How's that stuff looking?
We're looking good. We had a recent addition to the team. His name is Jonathan Sheridan as a business advisor. He's a current CEO of a multinational biotech company out of Madison, Wisconsin, here in my home state. Jonathan has done these, taken live biotech companies before. He's very tied into the University of Wisconsin. has access to lab space and scientists and graduate students to man the labs. And it's like access to people who buy DNA for research. I mean, the guy's like a gem, and he's graciously given us a bunch of his time to give us some solid advice on where we need to go. So the lab upgrade from a technical standpoint is not very hard. We will be looking for investors here in the near future, and I think we've got a really great program to get them securely invested in EDNA, where they have a good chance that they'll see some really nice returns on their investment, and guaranteed by EOS contract.
That's fantastic. As we kind of wrap up the show here, is there anything that you'd like to go back and touch on? Is there any parts of the privacy or the blockchain or anything more about EDNA here that people need to know about?
We covered a pretty good bit. I think you had the right question to keep it moving along. We covered most of what I've got out here. Telegram is also, I just mentioned our Telegram room. We maintain one of those, and I'm in there quite a lot. I keep it running in the background, and a lot of people who hover there and are helping EDNA will get me pinged if somebody new comes in with a good question or wants to talk to me direct. I'm very open to that, and I like breaks in my code. I like to put the code aside and go chat with people for a while and clear my head on numbers and stuff. So yeah, please drop in if feel free to drop in and ask anything you want about the project, and I'll be happy to help you and answer it.
Great. Yeah. And I mean, hopefully people listening to this, their brains are probably popping off with all kinds of questions. So go to the Telegram channel and ask those questions and be a part of it. That's one of the coolest things about blockchain and all of these interesting companies that starting up that I love is the accessibility of the founders and the CEOs with these huge ideas. And we just as community members get this opportunity to go ask questions directly to the people, these thought leaders, and it's such a cool opportunity. So don't pass that up. My EOS friends, go get involved. I'll be at the EOS Hackathon. I'm a mentor at the San Francisco Hackathon coming up here. It's only about a week out now. So I'm excited to meet a ton of the block producers, a lot of these hack teams that are in there. It's going to be really cool. Do you have any team members that are heading to the hackathon by any chance?
I'll be there.
Oh, cool.
And the day after, it's Scaling Blockchain. I know you're the MC, you're hosting.
Yeah. There it is, the Scaling Blockchain on Monday, the day after. So yeah, anyone at the in San Francisco for the hackathon, if you haven't already heard about Scaling Blockchain or got a ticket, I'll put a discount for the tickets in the show notes. But yeah, I'll be the MC there. That'll be fun. Cool. So what are you doing at gonna hackathon, Greg?
I'm just going to show up and hang out and meet people. I really don't have a need to sit down and hack out the code. I've kind of we've got a pretty good system here, and teams, and working with a team that's spread around the planet. I don't feel the need to sit and hack, but I think that having already deployed some contracts, we might even be able to help some folks out, who are struggling with the basics. Sure. And if not, it's always good to just go say, hey,
Yeah, I'm really excited. I mean, Dan Larimer will be there. Mike Novogratz will be on the panel judging the hackathon. Tons of the block producers will be there. It's fun to just hear all the ideas that come up in a place like that. I mean, it's just.
Oh yeah, the energy's got to be awesome.
Yeah,
it's got to be awesome.
I can't wait. Great. Well, I will see you at the hackathon, in just about a week here, and that'll be fun. Well, we are going to wrap it up now. So my EOS friends, thank you for coming. This is the EOS Podcast. This is Greg Simpson with EDNA, the founder. I'm Brandon Parker with the EOS Podcast, and we will see you next time. Thank you.
The money is not the prime asset in life. Time is, and your time is.